The graph of the function f of x equals 2 to the x power is translated up 8 units to get the graph of g of x. Use this information for 45 and 46. For each pair of values, tell which value is greater, the y-coordinate of the y-intercept of g of x, the y-coordinate of the y-intercept of f of x. Well, let's look at our graphing calculator. F of x is 2 to the power of x. We write that y equals 2 to the exponent of x. What does that graph look like? That graph looks just like that. Now, the other function is, it's translated up 8 units, so that is 2 to the power of x plus 8. What is that graph going to look like? That's going to look just like that. So, which y-coordinate is bigger? Well, certainly it's the y-coordinate of the y-intercept. Now, which is bigger? The output when x is 2 or the other output if x is 2? Let's look at the table. When x is 2, the output of the original function is 4, but the output of g of x is 12. So obviously g of 2 is bigger. Here, the output of x is 4, that's 16. The output of g of 1 is 10. 16, 10. Obviously, f of 4 is bigger than g of 1. We like the graphing calculator. Problem 46 continues on with 45. Let's see what 46 brings us. The graph of h of x is translated 12 units down from the graph of g of x. How is the graph of h of x related to the graph of g of x? Translated down from the graph of g of x, what would that look like? Translated down 12 units, that would be 2 to the power of x plus 8 minus 12, right? So that's going to be 2 to the x minus 4. What's that graph going to look like? Oh, we can't even quite see it. We would need to adjust the window for that. But we can adjust the window by saying that my minimum y is going to be negative 6. And now let's see the graph. F of x, can you see that? F of x, g of x, h of x. How is it going to relate to the original? It's going to shift down 4 units. This graph shows a transformation of the function f of x equals x squared. Brad says the equation of the function is g of x equals x squared plus 3. But wait, if we graph x squared plus 3, x squared plus 3, wouldn't we predict that the curve would shift up? That the vertex would still be on the y-axis? Let's change our window back to -10, +10, -10, +10. Okay, this cannot possibly be Why do we not agree with Brad? We do not agree with Brad because if we graph x squared plus 3, as we did here, that is what we get. We don't get a shift to the left. So no, we do not agree with Brad. We'd better stop here and start another problem set in just a minute.